This video is going to take a look at homework problems on page 176, and I'm going to do problem 61 and then problem 63. So 61 is 3/4 y to the 3/2 power minus 1/4. My 4 looks like a y. There, that's better. 1/4 y to the 3/2 power. Let's take a look at this one first. So I would like to be able to combine these. That would be the easiest thing to do. And to combine them, I have to have like terms. So let's think about what like terms are. Like terms have the same base. And most times we think of that as being the same variable, like x and 2x are like terms, or y squared or 3y squared and 5y squared. Those are all like terms because they have the same base. So let's check our example. Do we have the same base? Let's see, I've got a y and I have a y. Very nice. I also have to have, for like terms, I have to have the same exponent. So I need the same power or same exponent. So an example of that would be x squared and 3x squared, or 2y to the 5th and 3y to the 5th. So the exponents are the same in each case. So let's check our exponents. Well, let's see, I have a 3/2 in my first term and a 3/2 in my second term. So I definitely have like terms. And if I have like terms, that means that I can just combine the coefficients. Combine the coefficients. So what are our coefficients? Our coefficients are 3/4 and 1/4. I'm going to get rid of this number 63 over here. Let's just think about the 3/4. 3/4 times this stuff and 1/4 times that stuff, the y to the 3/2 power. If I were just going to combine fractions, like if I just gave you the problem 3/4 minus 1/4, you would say, oh, well, that's really easy. It's just 2/4. Right? We want to subtract the numerators, but the denominators stay the same. And then I'm going to reduce that, and I'll end up with 1/2. Now, this is going to be the same thing, even though I have this funny y to the 3/2. Like if I had an x here, say it were 3x plus 1/4 x, well, I would still combine it, and I would have 2/4 x plus or equals 1/2 x. But I don't have an x here. My like term is y to the 3/2. Y to the 3/2. So 3/4 y to the 3/2 minus 1/4 3 to the y/2 is 2/4 y to the 3/2, or 1/2 y to the 3/2. So here's my final answer, 1/2 y to the 3/2. Let's look at number 63. So 63 says x to the 4th y to the 1/2 plus x y to the 1/4 squared. All right, I'm going to look for like terms again, right? I'm adding, so I need like terms. And like terms require us to have the same base. Same base. Let's look at our base. Well, I've got an x and a y and an x and a y. I do have x's and y's, but I also need the same exponents. Do I have the same exponents? Well, let's see. I've got x to the 4th and x to the 1, and then I've got y, just play y to the 1 and y to the 1/4, and then one of these is being squared and the other is being raised to the 1/2 power. So right now I don't have the same exponents, which means I don't have like terms. But maybe not all is lost. Maybe I could do something to get like terms. So let's start off by considering what all of this means here. So x to the 4th times y all to the 1/2 power. Let's use some exponent rules here and multiply through by that 1/2. So if you're raising something to a power, you're going to multiply the exponents together. So I'm going to say x to the 4 times 1/2 and y to the 1 times 1/2, which becomes x to the 4/2 times y to the 1/2. Right, 4 times 1/2 is just 4/2. 1 times 1/2 is just 1/2. And now let's simplify that. 4 divided by 2 is just 2. X squared, y to the 1/2. So I'm rewriting this term right here, the x to the 4th y all to the 1/2 power, as this term down here. X squared times y to the 1/2 power. Now let's do the same thing with this second term. This guy here, the y and the x and the y to the 1/4, all squared. So let's multiply through by that exponent of 2. So let's see here, x to the 1 times 2 and y to the 1/4 times 2. That becomes x squared, and 1/4 times 2 is 2/4. You're not seeing that it's 1/4 times 2, which is 1/4 times 2 over 1, which is just 2 over 4. And if I reduce the 2/4, I'm going to get x squared times y to the 1/2. All right, so this term here, the second term, I've rewritten it. And now it's this term down here. All right, I'm adding up on top, so I'm going to add down below. Do I have like terms? Do I have like terms? Oops, I forgot my little square here. There, that's better. Yes, I do have like terms. I've got the same variable, and now I've got the same exponents, which means that I have like terms. And if I have like terms, I can add them together. When I'm adding like terms together, the bases stay the same. So x squared, y to the 1/2, that stays the same, but I have one of them over here and one of them over here, which means I have two of them all together. And here is my answer. Ta-da! My answer is 2x squared, y to the 1/2 power.